further ado, we're going to be talking. Jeff McGhee is going to give us a little talk today about what you see here. Jeff?
Sure.
Round of applause for Jeff. Welcome,
Jeff. So I guess before I get started, a little bit about me. Got a background in engineering. I got into writing code then in college when I realized you could do a bunch of homework problems with the same piece of code, stuff like that. So worked on getting engineering math into code. I mean, that was what my homework was. So kind of started extending that into other types of math. And I work at a startup in town, Variable Incorporated, do some work with sensor calibration and I guess color matching techniques and stuff like that using I guess data science. I don't think my role is 100% data scientist, but I do a lot of data science stuff. So enough about me. Also, I made the mistake of drinking a carbonated beverage, so if you hear some weird noises, sorry. Okay, so this is basically a short tutorial about the data science tools that are out there for anybody who's interested. They're free, open source, all in Python. So my goal is, if you know a little bit about Python or a little bit about data science, you're not going to be making a big leap at all to go into doing the stuff that I'm going to show you here. If you don't know about either of those things, it might be a bit of a leap, but at least maybe this will get you interested in learning. So, right here, the general data science goals. Well, I'll cover this other thing in a second. But so the general data science goals are: we want to tell a story of the data. Normally, you want to answer a hypothesis. This data that I'm working with, I just wanted something simple to make a tutorial, so there's not really a hypothesis that I'm going after here. But normally you want to do that because your boss says, hey, we have this data, we have this problem, we think there might be an answer there, but we don't know where. So that's what we want to do. And then lastly, so a big part of it also may be building a prediction model with like machine learning or some sort of other statistical model, something like that. So, so this data set is, it's about fatal car accidents. Comes from 538. I may click some of these links, I may not. Also, feel free, I don't want to talk at you, I want to talk to you. So if you have questions, just shoot them out. I don't care if you blurt them out, I'll stop and try to answer. This is about fatal car accidents from a statistics blog called 538. You can download it from their GitHub page. Also, this whole IPython notebook is on my Bitbucket account. And just a little side note, I did this exercise on my own before I looked at the 538 article. I didn't really want that to influence what I was going to do or show you. But you can check out the article there as well if you follow this link in the notebook. So the main tools that I'm using are IPython notebook, which is what you see here. This is a really cool sort of interactive environment for doing, I would say, prototyping of your code. You can run full-on analyses in here, but you won't put this into production. You should take whatever algorithms you generate or work with in here, put it into some sort of real production system. Pandas is a Python library that is extremely powerful, and I'm not really as good at it as I would like to be, but it helps you work with unstructured or all different types of structured data fast. So the main class is called a pandas data frame, and there's a whole bunch of statistics and different ways that you can query these, just real quick one-liner type powerful things. Most of the data that I work with is all in the same or a similar format, so I don't have to use it for that kind of stuff very much. I do use it here though. NumPy is a big Python matrix math library, and it's all has a C back end, so it's really fast. SciPy usually goes alongside NumPy. It's got does a lot of different interesting scientific things related to math. Scikit-learn, that's the machine learning library. That's pretty much the biggest in Python, unless you want to get into neural networks. And I'm going to use a little bit here. It's pretty easy to work with. Matplotlib is a plotting library. Seaborn, another plotting library. And MPLD3 and Bokeh are basically allow you to take your native Python plots and turn them into JavaScript and HTML so you can embed them in web pages and whatever else. So I use that here to make these plots interactive and a little more useful. Okay, so here we go. I'm not going to sit here and read this code to you, but basically what I'm doing is, if you know Python, all the importing everything there, and this is called a cell. And so the cool thing about IPython Notebook here is all these variables sort of get stored into this like running environment that you have. And so you can access them later in lower cells. And so it allows you to prototype real quick, like I said. Okay, so I'll import the data as a data frame object. And so another thing, the data either had state names or abbreviations, and I make a map, and it had the opposite, so I had a little JSON file to map between the two, and I'm importing that as well. So for initial exploration of the data, oh man, this resolution is small. So we have states with our data, basically the states and the names, and then for every state, we have the number of drivers involved in fatal collisions per billion miles, percentage of drivers involved in fatal collisions who are speeding, percentage of drivers who are alcohol impaired, who were not distracted. I found that interesting that they use that, but I guess a good idea might have been to flip the numbers there and make it show distracted. I didn't do that, but that's probably a good thing to do if you wanted to do some meaningful analysis here. And then drivers who had never been in another accident, but they died in this one. And sort of a little bit unrelated, but it was part of the data set, is car insurance premiums and losses incurred by the companies for collisions. So I guess it is kind of related. So anyways, the first thing we're going to do is look at some statistics for the data. And so right here, I'll calculate for these 4 lines right here. This is working with the pandas data frame. This calculates for each of those categories there, the mean, coefficient of variation, the minimum, and the maximum. So, and there's a whole bunch. Yeah, here's some other ones. Median kurtosis skew. There's some more probably. And so, I mean, just real quick, you don't even have to know much statistics. Well, you don't have to know any to get these numbers. You may need to know some to understand what they mean. But so yeah, and then I combine that to make a new data frame. And then real quick, you can just see if you run a print statement on a data frame, this one called stats that I made, it'll print it out real nice for you. So this is all sort of just exploratory things so you can look and try to get a feel for what's going on in your data. So why did I choose these statistics? Well, they're not very fancy statistics, but the mean will probably be important to at least understand. The min and max, again, it gives us a bit of idea of, you know, the scale of what we're looking at. And so the coefficient of variation is the standard deviation divided by the mean. And so it allows us to sort of look at all of these together here and see like which ones are more spread out compared to the others. And so the higher the number, the more spread out it is. So it looks like speeding percent is varies widely among the states. Insurance premiums or deaths per billion is the next highest, and then insurance premiums. And then, of course, with standard deviation, you have like the 2 standard deviations away from the mean. If you have a normal distribution, you're looking at 95% of your data. So that's something that you can look at pretty easily if you just look at the standard deviation. Okay, so what I decided to do, pretty much because it's a neat thing you can do with scikit-learn, and it's pretty easy for people to get to grasp, is cluster the states. So I'm just going to do a cluster or use a clustering algorithm and see if it'll, find a way among those, however many dimensions it was, 7, I think it's 7 dimensions, which states are close to each other. How can we group them? And so for that, I use k-means clustering. It's simple. It's one of the simpler clustering algorithms. In scikit-learn, though, they're all equally simple to implement, so that's nice. But this is simple. You may have heard of it. Basically, you're going to use, it uses Euclidean distance among those 7 dimensions to group your states in this case. And so let's see what I do here. By the way, I made this a while back. I reviewed it, of course, but so just keep that in mind. So I define we want to make 4 clusters. That's the thing with k-means and a lot of other data sets. You have to or a lot of other clustering algorithms, you have to define the number of clusters that you're after. There's some really computationally intensive ones that sort of search to find the proper number of clusters. For this, I didn't think that was necessary, but those are out there if you want to use those. Oh, and so importantly, I said Euclidean distance, but I did not say that the important thing about it is we want to normalize all of the data, because remember we had these large ranges. We had this one, insurance premiums ranges from 641 to 1301, while deaths per billion ranges from 5.9 to 23.9. So if you're going to cluster those, we want to make sure that basically we would have really weighted clusters towards the insurance premiums. And that would be the only thing that we'd be clustering on, which is no good. So normalize everything based on its highest value, get everything between 0 and 1, and then we'll cluster them. And so this is a little more involved, but and I got a little sloppy in some places, but basically what we get here is clusters, and then I took a note of what the percentile limits for each category was to basically the 10th, 20th, 30th, up to 90th percentile of each category. And so what we can do is look, cluster numbers 0 through 3, what sort of percentile they are in based on the national mean, or the national data. So what's the mean of cluster 0 in deaths per billion is in the 20th percentile nationally. So that's could definitely be some useful information. You could probably make a neat little article about that or something. And so this is the first plot that I have. It's called a violin plot. You can make it another one-liner here with Seaborn, where it is SNS. I don't know why they prefer to abbreviate Seaborn as SNS, but they do. So one line, you get a violin plot of your data frame. It works well with pandas. And so basically what this does is this shows us among those 7 features that we have, we can look at what the distribution looks like. And this is, so the shape of this is roughly the distribution. There's like a kernel estimation that they use to build this curve, and it's not like, it's not perfect, but it gives you an idea. It's a nice way to look at a whole bunch of data and see how it's distributed. So we can see, like for instance, on this not distracted percentage, most people are up here, but some's way down here, you know, very, very few. And so with the clusters, we'll look at the distributions for the clusters compared to this and see, you know, what sort of happened there when we clustered all the states together. So yeah, we have some cool stuff, at least I think it's cool. The 4 clusters of the states generated by k-means. And so k-means results depend on random initialization. So every time we run it, we'll get slightly different numbers. This data set, because some of it's pretty widely distributed, it does differently. There's 2 sort of scenarios that it likes to converge in. So that's something that you should definitely keep in mind when you're going to use it for a real problem. And all this stuff, you don't need to know this to do data science, I don't think, but this is just how to plot it. And so it's not too terrible if you get into it, but this is how we make these interactive figures. So if we look here, this is the first cluster after I've run that. And so what you can see is really we have a small distribution of deaths per billion. Let's look through the rest of them. So not entirely. Clusters are sort of forming around deaths per billion, but you can see here that mostly we've shrunk how varied our data is for the cluster, which is good. And here in the background is the original distribution of the full data set. So yeah, over here is just, again, those same percentile statistics that were showed in that data frame up there. But so now what you should start to notice is this is kind of informative, what's here. And you can cram a lot of information into this, and this is sort of getting popular in big newspapers and stuff will start doing stuff like this, infographics, and with, you know, real data, and the whole story is here probably in these 4 plots for these clusters. And so I think that's neat. Maybe you do, maybe you don't. So, okay, so now something that we'd be interested in is how are these clusters shown on a map, right? So which states are in these clusters? Of course, we could print a list, but people like to see maps. So the map was a bit of a pain. Anybody who's done maps probably understands that. But it's not terrible if you just grind through, and then, man. Let's see, there it goes. My scrolling doesn't want to work on there. Well, we're having a bit of a screen resolution. Oh, here we go, I can drag it though. Okay, so it looks like these are our clusters. We have honestly, we'd have to look at which color was which number, but you can sort of look here. The yellow ones looks like they have low-ish deaths per billion. The green ones may be a little higher. The red ones, actually, I think these are the lowest, and the blue ones have some high states in here. So Arkansas, Tennessee, not very good. So we're clustering on more than deaths per billion, but I guess we can look here and see deaths per billion. Like I said, I just want to show you guys the things you can do. This may not, you can take this as valuable information or not. So, one thing that we may want to do after that is somehow rank our states. At the time that I ran this, these were worst to best on death per billion cluster rankings. But what you may want is a full scoring metric across the whole 7 features, and find a way to score, is this cluster worse than that cluster, based on however I weight all of these different averages that they have of these features. And so you could use that in the future. If you thought this data set was large enough, you could use this in the future to say, well, these states now fit into this cluster in 2016 that are, these were the bad states in 2015, and this state now compares to it. Things like that. And that's sort of like a machine learning type application of this. But pretty much, unless you want me to start going through the code line by line, this is it. So, any thoughts, questions? Everybody's pretty quiet, but yes.
So you basically clustered some states together, right?
Yep.
What kind of meaning would you get to those clusters?
Sure. So you get there similar. So with the clustering, that's a great question, and that's why I said, well, there may not be a whole lot of meaning actually in what's happening here. But so what that is actually giving us is the Euclidean similarity of those states across the 7 metrics that we clustered them. So the main purpose here is to show you that, hey, that was easy to do in Python, and if I have something I care about, I can do that. So, but yeah.
So at this point, what would you do if you wanted to decide what the key variables were? So if you had to throw out variables, throw out columns, what would you do next?
Like if we wanted to just remove.
To predict which cluster those states should be in the future. And you wanted to get it down to 3-4 variables that give you 90+% confidence that next year they're going to be in this group.
So that's sort of a different problem. But so if you want to, I guess, predict what group someone's going to be in next year, then I mean, this is really static data for a single year. So in my opinion, it might be pretty difficult to do that, but I think you would need trend data from the past to start.
Do like a predictive regression analysis.
Exactly.
And then take that and cluster that data.
Yes. Yep. So so I guess what I was getting at more is if you have the data from next year, you can say, well, last year we had this cluster of states that were the worst, and we're calling them the worst based on whatever scoring metric we decided. And now this year, this state fits in there with those states that are bad. And so it's not really a prediction, you're just reclustering based on your old cluster metrics.
Okay, so let's say it costs you to gather that data, and you want to get down to what are the data points that I need to spend money on, that I need to spend time on to gather, to be able to continue doing a reasonable clustering.
Sure. So all of this is, so you talk about looking at which features are important.
Right.
So in order to look at the features that are important, you have to take some domain knowledge that you have about how you would score these clusters, because the clusters themselves they're just on this data that we have here, and we haven't defined what makes one good or what makes one bad. And so we would need to, I guess, like I said, the next step is to make a definition of, you know, or a scoring metric of, is this cluster a bad cluster? And then you could start looking at how different statistics influence that scoring metric. And so that's, I guess that's what I'm getting. Does that make sense? Does it, yes?
I think what he's asking, if it's from understanding that if you have two sets of data which are highly correlated with each other, you'll necessarily in both of them, you can gather one of them and sort of infer the other. So it's really just a correlation problem of, did it say highly correlated with this one, maybe you only got one.
Yeah, so you asked me like, how do you would have to know what correlations you want to try to find if you want to try to find those.
Right.
Or you could look for outliers, which would be the
Sure.
most interesting thing
Yeah.
possible.
Is there a way in the clustering algorithm to pull out which of the 7 dimensions had the least impact on definition? And there's some clustering algorithms do that.
Right, so this one, they're all weighted equally because we normalize everything between 0 and 1. So I guess at that point, one thing, I'm not sure retroactively if there's a way to do that with k-means, but what you can look at is basically if you have what your widest distribution is, your points that are the most distributed in that 0 to 1 range, those will probably have a big effect on your clusters. So.
So have you used other plotting tools like D3.js or something like that? And if so, like where, compare that to Matplotlib, I guess.
Okay, Matplotlib is fully like native OS GUI plots. And so what, so I mentioned up here, MPL D3 actually has a converter, wherever I import it here. Let me follow this link here. So this has a converter to convert, it basically interprets to D3. And so that's what I'm using there, and all the plots besides the map. For the map, I used Bokeh simply because they already had a mapping feature built in, and it was a lot easier. But yeah, there's also, I mean, there's a lot of ways that if you're familiar with D3 and familiar with web development, you can pull data out of Python and pump it into D3 and do stuff that way. So. Yeah, right, exactly. Yeah, the notebooks are just a web page, so they're doing that. And yeah, there's a way to do that behind the scenes too. Anything else?
The next IPython notebook version will also have a JavaScript kernel, so you can run native D3.
Yes, I was hearing that. So yeah, a warning about some of these tools. I ran into it this morning. If you work in Python, it's good to use a virtual environment. I didn't for this project. And I updated Seaborn and it broke everything. So a lot of these tools are new and under heavy development, so keep that in mind. Anything else? Nothing? Well, tonight I'm giving an overview talk at the Chattanooga Big Data Meetup. It's going to be here at 5:30. Just an overview of machine learning. So some of these like prediction questions that you were asking would be addressed there a little better, hopefully. And then also I'm up here talking at you because I guess I'm in charge now of a Chattanooga data science meetup. And we have some We had a really good turnout on Tuesday. A lot of really talented people came, more talented than myself, definitely. And so I'm excited to be in that environment and learn from those people and learn from other people, because everybody brings an interesting way to look at data, and that's a neat thing about that. So if you want to look into that meetup and join, you can see I at least kind of know how to do some stuff, so I can teach you some stuff, and other people can too. So, yep, that's all I got.
Cool. Go.